Hi there, my name's Elissa and I'm here with PHillyCAM to talk to you about what sound is and how it travels. Hopefully this will give you a better understanding so you can get a great recording for whatever project you're working on. So let's get started. Sound is a pressure wave, which is created by vibrating an object. These vibrations set particles in the surrounding medium in a vibrational motion, thus transporting energy through the medium. So sound can travel through air, which is most common, water, and solids. These particles oscillate back and forth about their individual equilibrium position. In short, sound is amplitude plus wavelength. Like I did before, an occurrence makes molecules vibrate and then they travel in waves. So when I clap, the air around vibrates and travels in a wave pattern to your eardrum. So once again, sound travels as sound waves. The bigger the vibration, the greater the amplitude of the waves and the louder the sound. When these traveling, vibrating, wave-patterned molecules bounce against your eardrum, that's what we call hearing. So we refer to loudness as intensity, and we measure intensity through decibels, also known as dB. We can use electrical signals to amplify sound. For example, if a channel or device is amplifying the sound by 3 decibels, that means the output is 3 decibels louder than the input. So the threshold of sound is 0 decibels. A rock concert has an intensity of 120 decibels. Sounds of 120 decibels or greater can cause people pain and ear damage. And one great way that you can measure decibels is by downloading a free sound meter on whatever smartphone you have, and it can tell you how loud an object is. So, it turns out that air is able to support not just one wave, but many different waves simultaneously. This means various pure tones can be mixed and sent through the air at the same time. This is where music, speech, and other noise comes from. So every sound has a range from a high to a low pitch. The pitch of a sound depends upon the frequency of the vibrations that cause it. The frequency of a sound is the number of complete waves or vibrations that go past a particular space each second. So the more vibrations per second, the higher frequency and pitch sound. The fewer vibrations per second, the lower the frequency and the pitch sound. And here is a drawing to show you an example. Frequency will come more into play in post-production. We can cut or boost certain frequencies to get a particular sound. It is also important when deciding which kind of microphone you want to use in a given situation. So, what are some of the things we should keep in mind about how sound travels as we're recording? Well, first, consider that the goal is to get these traveling pressure waves to hit your eardrums, so direction matters in addition to your environment. For example, it can be difficult to amplify sound outdoors in a wide open field because there's nothing for the pressure waves to bounce off of. The materials in which you're surrounded by also matters because it will determine the wave's ability to bounce around or to be absorbed. Hard and smooth surfaces, such as metal and tile, can produce reflective sounds. We call this reflectivity. When sound travels in a given medium, it strikes the surface of another medium and bounces back in some other direction. The waves are called the incident and the reflected sound wave. So the first wave is the incident wave, and then after it bounces off something, that's the reflected sound waves. And where this can get really tricky is if you are in a bathroom, for instance. Your voice can just be bouncing around off the tiles, and it'll make it difficult to figure out what the incident wave is. Reflectivity is something we usually want to try and avoid when producing or recording because it just, like I said, makes it difficult to get a clean sound. Another form of sound bouncing around a lot is something called reverberation or reverb. It's actually a desired effect a lot of times in vocals for music. But what reverberation is the persistence of sound after the sound is produced. A reverberation is created when a sound or signal is reflected, like we were just talking about, but it causes numerous reflections to build up and then decay as the sound is absorbed by the surfaces of objects in the space. So that could include furniture, people, air. There are lots of different kinds of reverbs, and these are just a few. For example, there's chamber, hall, cathedral, and as maybe you could have guessed, they're named as such because they're describing the way that sound moves about these particular spaces. That leads to something that I just mentioned. Absorption is really important and will help you get a clean sound. Things that will absorb sound are soft, such as carpet or foam or mattresses or blankets. A big thing that people will use to treat a room or to make it so sound can be better absorbed in a space are moving blankets. You can very easily just go into your closet, which also already has clothes in it, which will absorb the sounds also, and hang up some moving blankets around the space. It's really important to not forget the floors also. All of this to say is maybe don't record your interview in a bathroom, but rather in a room with carpeted walls. Anyway, thanks for listening. I hope that you have found this tutorial helpful. Next up, we're going to talk about how microphones work and how you can select the perfect one for your given scenario. Thanks again.